We've been solving trig equations for a while, but we're going to look at what that means in more detail. If we look at arc cosine of 1/2, cosine of theta equals 1/2 on the unit circle, or give the general solution, these have three very different answers. Remember that arc cosine is a function. So when we have something that's a function, there's going to be only one output for any given input. Cosine is restricted to the unit circle, so the only solution within the unit circle that we look at for arc cosine is restricted to the first and second quadrant. So we can say that pi over 3 is our only answer to arc cosine of 1/2. However, when we start looking at cosine of theta equals 1/2 on the unit circle, there are two answers. Now we have this one, but we also have the answer in the fourth quadrant. And you can say that that's negative pi over 3, or you could say it's coterminal angle at 5 pi over 3. And we would say both of those, pi over 3 and 5 pi over 3. Now this is not a coordinate pair, just the solution set is both of those points. Either theta equals pi over 3 or 5 pi over 3. And then if we start talking about cosine of theta equals 1/2, give the general solution, you need to know that that is pi over 3 plus all of its coterminal angles, so 2 pi n, and 5 pi over 3 plus 2 pi n. You can think of this kind of as the difference between a function and solving something like x squared equals 2. If you solve something like x squared equals 2, you get positive square root of 2 and negative square root of 2, which is what we're getting here. And then here, what we're having is, if we were to graph cosine, and we have a graph of cosine, well, where is it 1/2? Well, it's 1/2 every time that it crosses that y equals 1/2 line. So that's infinitely many times. That's why we have the plus 2 pi n, because they're all a period apart. So these are three very different questions, and you should know the difference between them. How do we get the general solution specifically? We're going to add the period times n. So this is multiplication, not a function that takes in n as an input. It's the period times n. So for sine, cosine, secant, and cosecant, we'll use 2 pi n. For tangent and cotangent, remember they have a period of pi, so we'll use pi n. So how do we solve trigonometric equations with expressions inside the trig functions? That's where things get confusing. When we have not just cosine of theta equals 1/2, but cosine of 2 theta plus pi over 2 equals 1/2. So the first thing that you want to do is isolate the trig function so that there's nothing else on the same side of the equation, which we've done. Then we find the general solution for this. So find the general solution for cosine of theta equals 1/2. That's what we did here. We got pi over 3 plus 2 pi n and 5 pi over 3 plus 2 pi n. Once we found the general solution, we set those general solutions equal to the input expressions. So let's do that here. Let's see. What is the general solution for sine being 1? So sine is already by itself. Sine is only 1 at pi over 2. But we have to write the general solution, so it's plus 2 pi n. Then we want to set that equal. So this is doing step 2. Step 2 is saying the general solution to sine of x equals 1 is this. But we don't have just sine of x, we have sine of theta plus pi over 4. So we're going to solve this equation for theta. Subtract pi over 4, pi over 2 minus pi over 4 is pi over 4. So once again, we found the general solution, or we found that the basic solution would be pi over 2. We added the period 2 pi n to get the general solution, and then set that equal to our input. Here, where is cosine equal to negative square root of 2 over 2? Well, that happens at 3 pi over 4 and 5 pi over 4. So our general solutions are 3 pi over 4 plus 2 pi n and 5 pi over 4 plus 2 pi n. So those are not final answers. That's not what theta equals. That's what the whole input equals. So now we can divide by negative 2 on both sides. We'll get negative 3 pi over 8 minus pi n. Or when we divide by negative 2 over here, negative 5 pi over 8 minus pi n equals theta. So here are our solutions to this equation. Tangent is different. Remember, tangent has a period of pi. So our solution would be at 3 pi over 4 plus pi n. And then we set that equal to our entire input. That's the pattern here. We find the general solution and then set it equal to the entire input. Now we have to subtract 5 pi over 6 on both sides. That's going to be a little harder to do, so we need to get a common denominator. This will be, common denominator would be 12. That would be 9 pi over 12 minus 10 pi over 12. Yeah, so negative pi over 12 plus pi n equals 4 theta. Now we divide by 4, and we get negative pi over 48 plus pi over 4n equals theta. So, again, the process, get the general solution for the original equation. If you treat this all as one big thing, get the general solution, that's what's in purple, and then set that equal to the input. Last one. Well, where is sine equal to 1? It's equal to 1 up here, and that's at pi over 2. Get the general solution, so that's plus 2 pi n. You'll notice that I'm using 2 pi n, not 2 pi n over 3. We're going to get that when we solve this equation. So 3 theta plus pi over 3. Oh, that got very sloppy very quickly. Plus pi over 3. There we go. Subtract pi over 3 on both sides. And once we subtract pi over 3 on both sides, we divide by 3 on both sides, giving us our final answer of pi over 18 plus 2/3 pi n. All right, that's how we solve trig equations with inputs that are not just a single variable.